All right, greetings. So let's do some parametric modeling. Now I realize you guys probably do not have Inventor, so that's okay if you do. That's great for you, but we don't really need it. What we need is a process. So for parametric modeling, uh, I'm going to do this example and then you'll have to do it. And where you guys are going to fill it out for your answer, if you don't have Inventor, will be on Google Sheet that I will share with you. But basically, we're going to draw this shape without dimensioning anything. We can do constraints, but no dimensions. And then we will put in the parametrics based on this chart. Okay, so I'm just going to draw this quickly. So I draw my cam, which you may or may not have to do, but I draw a circle, and I draw another circle, and then I go up somewhere and I draw a circle. I make sure that these circles are on the same vertical using my vertical constraint. And then I draw some lines to connect. I want to make sure those lines are tangent to both of the circles. 1, 2, 1, 2. Very good. And then I go and I trim out the excess. So I have a cam now, and that's great. And with that cam, I am going to start doing my parametric modeling. So the first thing I do is I want to set a value. This could actually be named anything. Like I could name it like base value or whatever, but I'm just going to name it D because, most of my things are D, and I'm just going to leave that in there as 1, and that's fine. We'll start with 1. Okay, done. And then what I've done is for the video lesson, we're going to keep bumping back to this, but I also have set up a chart, which I'm going to pull out actually and bring into my other. Let's do this, close this, and I'll bring it here. So I have a chart here, and it's kind of giving us what all our values is. So we're going to say this is 1 and 1, or I'll get back to the values later. But we're going to start that off with D is 1. Now D0 is the radius of that circle, and it is twice the nominal diameter. Okay, so for this, I would say this is D0. If we look at the picture, I would say that's twice the nominal value. So I'd say 2 times D. It's twice what D is. It's 2 times the nominal value. And you can see right here the dimension is D0. And it puts it in as a function as 2. So very good. And I'm just going to go through like that, and then I'll get back to the Excel sheet. This is not what I want. I want this. Okay, so that's D0. D1, if we look at the Excel sheet, is equal to the nominal diameter. So for this, I can very easily go to dimension. This will be D1 as you see, and I want this to be equal to D. So now it is equal to D. You see it's a 1.0, which is equal to D. Going back, the next one, the offset is going to be twice the nominal diameter. So D2 is the offset, and that is right here, and that is twice. So we've already done that equation, so that should be pretty easy. So from here to here, this is D2. This will be twice 2 times the nominal value, so it'll be 2 times D. There we go. And then I believe the last one that we have to worry about is the hole diameter is going to be fixed at 0.5, so I can figure out what that is, and then the thickness, which is the extrusion, and the extrusion taper. Okay, so this hole is fixed at 0.5, so I'm not going to do any of these. I'm just going to do a 0.5. Done. That is fixed. And then I'm going to hit finish sketch, and I'm going to hit extrude, and this will also be at 0.5. Now, the extrusion distance is going to be, which D is that? The extrusion distance is going to be D4. Whenever you extrude something, it creates a taper as well after. So like D4 will be the extrusion thickness, but the taper thickness will be D5. So if you ever had to change the taper, there's your D5. So like this one's the first one, that'd be D4, it would come first, and then the taper would also come, and that would be second, and it's 0. So I've got these set, and I click OK, and then if I go to my function chart, you can see I've got all of my values in here. I got D0 based on the formulas. And what's cool about this, if I can scrunch this over, what's cool about this is now if I wanted to edit this, I wanted to say, well, you know, my D value is going to be 2. I could do that, and then my D value changes to 2. And we are all set to go in that regard. And not only that, but it changes all of my nominal values here accordingly, which is cool, because if you have one thing that everything else is based off of, you can quickly do modeling. Like for a cam, we could quickly model several different sized cams, which is why this is good to start. What you would have to do is, if you don't have Inventor, and I'm going to actually bring my Inventor over to the other screen so I can just copy these formulas down, is you're going to go in the chart, and basically you're going to put what the equation is. So like this is 2 times D, this one is D, this one is 2 times D, this one is fixed, so it's just 0.5, 0.5, and 0. You put all of the equations in that you would be using, and then for values, you just go equals, this would be D, so equals D, and then this would be equals 2 times D, and then this would be equals D, and this would be equals 2 times D, and this would be equals whatever's here, equals whatever's here because it's fixed, and equals whatever's here because it's fixed. And what's cool about this is I can bring my parameters chart back in here. So if I change the D value on here to be, let's say, 2.5, and I come back over here and I change this value to be 2.5, you should notice I got a 5 for D0. Whoa, shouldn't have clicked that. I got a 5 for D0, 2.5 for D1, and a 5 for D2, and then 5, 5, 5. So on Excel, you can actually run the whole thing without having to model it. But if you have the ability to model, it's still cool. So this is parametric modeling. You're going to do this exact cam. So if you have Inventor, you will be drawing this on Inventor, obviously. And the only thing that's changing is I'm going to give you the Excel spreadsheet with the actual dimensions that were from the assignment. So they're going to be a little different. Your formulas are going to be a little different, but you're going to get basically the same thing if you draw it. You're going to get a cam that you can then change. Now, what I would do typically to test for this is, like, typically I'd have you draw it, and then I'd ask for, like, I don't know, I'd have you go into the eye properties and like, okay, now tell me, you know, what's the area of it when the D value is 2.5. I can't do that for this to check if you're right. So what you're going to be handing in is just that you know how to lay it out. If you do have Inventor, you don't have to go back to Excel. You could actually snip me a picture of this instead and just post this. That way you don't have to do all those formulas twice. But if you do not have Inventor, you have to lay it out this way. And you know, you shouldn't feel like upset about this. You don't actually have to draw it in Inventor. And if we were doing this in class, like in lecture style, I would have you actually be writing all of this stuff out before I let you do any modeling. Because the thing about this is, like, let's say D1 was wrong, right? Like D1 was wrong. It was off. If I go back, like, and I put this D1 formula in, and it should have been, you know, instead of being equal to D, it should have been like half of D, for whatever reason. And I go back, I'm like, oh man, D1 is wrong, and I delete it, and I come back, that ain't D1 anymore. It's D6 now. Now that's not really an issue here. Like if it was supposed to be 0.5 times D, I could change that. And that looks ridiculous. But The issue here with this is on the parametric chart, your D1 is still always going to come up as D1. So what you have to do is you actually have to go in and change this to be D1 now if you want this to be D1 and things to reference it. Like I said, in this one, it's not a big deal. There's not a lot of things. But in the next two that we're going to do, because we're going to do two more of these after this one, is purge unused. Is you're going to have several that are going to be referencing each other. And if you mess one up and delete it and then go and fix it, all of a sudden you got to go change this or change all of the other ones to reference it. Like, because D1 didn't exist anymore. So you got to go fix everything so that D1 does in fact exist. So you want to be very careful when you're doing this. Why I always make people plot the whole thing out ahead of time. So they actually have to just go, okay, D0, this is the formula, D1, this is the formula. And I find that works very well. It causes less mistakes because one mistake in this can affect, 6 or 7 other dimensions. And that's no good, and then you don't get the answers you're looking for. So this is the first taste of parametrics. I will post this with the video with what you're going to have to do. The cam, if you are drawing it, is going to be based on this cam in 8.1 parametrics. And then the next one we're going to do is going to be this one right here. We're going to do this one based off of this information. It actually gives you some of the formulas already, so that's great. But some of them you're going to have to figure out for yourself. And we're going to go through that next week. Or probably later this week. So that is it.